So we're going to integrate this expression, rather complicated expression, but the important thing, the pertinent thing about it right now is that it includes a sine and a cosine function. So this is actually a product of trigonometric functions, and when that's the case, very often the rule, or the guideline at least, is that you will let u equal the trigonometric function that has the more complicated power. Not simply the argument as it was in example 2, but let it actually be the trigonometric function itself. So we'll proceed the same way we did before. We'll do it with two methods, and the first method is the one in which we just ignore the limits. Okay, so let's ignore the limits for the time being. And we are going to let u be equal to sine of 2 theta minus 1. Now note that we don't let it be sine cubed. Oops, sorry about that. We're not letting it be sine cubed of 2 theta minus 1. It's just sine of 2 theta minus 1. So let's differentiate that. With respect to theta, theta is our variable here. Differentiate sine, you get cosine of 2 theta minus 1. Okay, and then if we multiply by the derivative of what was inside, the derivative of the argument, we get 2. So, multiplying across, usually it's dx that we're trying to get on its own. In this case, it's d theta we're trying to get on its own. So it's going to be 2 cosine 2 theta minus 1 d theta. And then if you want to get d theta on its own, you have to divide across by everything that's attached to it. So 2 cosine 2 theta minus 1. Okay, so this is what we have at this point. U equals sine 2 theta minus 1. That was our first important piece of this, and the other part of the jigsaw is getting d theta on its own. So we're going to ignore limits. Okay, we're going to ignore limits, and we're going to have that the integral of sine cubed of 2 theta minus 1 times cosine of 2 theta minus 1 d theta is actually equal to, well, sine 2 theta minus 1, that's u, and this is cubed, so it's going to be u cubed by cosine of 2 theta minus 1, and then replace d theta with du over 2 cosine 2 theta minus 1. Now what happens here, and what has to happen, because if it doesn't, we're going to have thetas and u's together, which we simply can't divide. The cosine 2 theta minus 1 will cancel, and you're going to have the integral of u cubed du over 2. So we're back to a power term. These very often break down into power terms. Bring out the 1/2. So it's 1/2 times the integral of u cubed du, which is just using the power term, increase the power by 1, divide by the new power. So it'll be u to the power of 4 over 8, or 1/8 of u to the power of 4. Now there would be a plus c, okay, but we're going to ignore that because we're going to put the limits back in. Okay. So now, if we look back at the original question, the limits were from from 0 to pi over 4 of sine cubed 2 theta minus 1 times cosine 2 theta minus 1 d theta. We're now saying that's equal to 1 over 8 times u to the power of 4, but u is sine to the power of 4 of 2 theta minus 1. Okay, and that is going to be from 0 to pi over 4. Okay, well, that's going to be 1/8 sine to the power of 4, 2 times pi over 4 minus 1, minus 1/8 sine to the power of 4 of 2 times 0 minus 1, which is 1/8 sine to the power of 4 of pi over 2 minus 1. Now, that looks like it's something you can simplify, but you can't actually without a calculator. So let's leave that like that. This would be minus 1/8 sine power of 4. 2 times 0 minus 1 is just negative 1. Okay, and we can leave that as it is as well. Okay, you'll probably simplify this a little bit, but it's not really worthwhile doing that. And that's a perfectly reasonable way to leave your answer. Okay, it's not a very tidy answer, but it's perfectly good. Okay, that's method 1, where we don't change the limits at all. Now, let's look at method 2, and this time we are going to change the limits. Method 2, changing limits. Okay, so this video is getting a little bit longer, so let's see if we can skip out through some of the drudgery. So we're letting u be sine of 2 theta minus 1, and we've already, I'm just going to steal from up above, d theta is equal to du over, it was 2 cosine 2 theta minus 1. I'm pretty sure, let me just check, 2 du over 2 cosine 2 theta minus 1, that's it. Okay, now we also have to change our limits. Okay, so we have u is equal to the sine of 2 theta minus 1, and the top limit, xt, was pi over 4, so that will mean the top u limit will be sine of 2 times pi over 4 minus 1, so ut is going to be the sine of pi over 2 minus 1. Okay, the bottom limit was 0. So that's going to give you u bottom. The bottom limit is going to be sine of 2 times 0 minus 1, which is simply the sine of negative 1. Now that's equal to minus the sine of 1, but since we didn't change it up above in method 1, we'll leave it this way right now as well. It's correct either way, whether you say negative sine of 1 or sine of negative 1. Okay, so now we're ready to complete our substitution. So the original question was the integral from 0 to pi over 4 of sine cubed of 2 theta minus 1 times the cosine of 2 theta minus 1 d theta. And we're going to now say that this is equal instead to, okay, the bottom limit is now going to be the sine of negative 1. And I know this is unusual, but the sine of negative 1 is just going to be a number, so it's perfectly fine. And the top limit is going to be the sine of pi over 2 minus 1. Okay. Sine of 2 theta minus 1 was u, and this is cubed, so it's going to be u cubed by cosine of 2 theta minus 1 by, replace d theta with du over 2 cosine 2 theta minus 1. Okay, the cosine 2 theta minus 1 will cancel. I'm going to pull out the 1/2. I'm working a little bit faster than I did before. Okay, so it's going to be 1/2 times the integral of u to the 3 du from the sine of negative 1 to the sine of pi over 2 minus 1. Okay, well, you integrate that. You're going to have 1/2 u to the 4 over 4. And it's going to be from the sine of negative 1 to the sine of pi over 2 minus 1. Now remember, the big thing about this is we're not going back to x's. We changed the limits. And when you change the limits, you don't go back to x's. Okay, you're going to have 1/2 by u to the power of 4 over 4. So multiply the bottoms. That gives you 1/8. U to the power of 4. Substitute in. That's going to be sine to the power of 4 of pi over 2 minus 1 minus 1 over 8 times u to the power of 4. Oops, we're replacing u now. Times the sine to the power of 4 of negative 1. Okay, and that's it. And hopefully it's the same as what we had before. It seems quite a long way away, but let's see if we can fit them together so that you can see. And yep, it looks good. Okay, thank you.